All right, welcome back to another FAANG level mock interview. For this one, we brought on someone that wanted to come on. He's a current coding bootcamp student, so he's still pretty early on in his process, but he's been a part of our community for a while, and I just want to give him the opportunity to, try this type of interview out, see what it's like, see what he still has to learn. Just a heads up, this turned into more of a coaching session, but I feel like a lot of the advice and the way that Daniel guides him through is pretty solid, and I think it's going to be helpful for a lot of people out there. But Daniel's going to be the interviewer. He's been a software engineer at Microsoft for 10 years. He's been a software engineer at Facebook for 7 years, and then he's currently at Formation, just helping people accelerate their careers. So hope you like it. Enjoy.
All right. Well, hello, Tin. My name is Daniel. Am I saying your name correctly? Tin, is that right?
Yes. Hi, Daniel. My name is Tin. You got it right. Yep.
Awesome. Nice to meet you. And thanks for taking time on is it Friday afternoon, maybe where you are? It's Friday afternoon here. So happy Friday.
Thank you. Yeah. Happy Friday. It is around 4:00 in California here. So.
Oh, awesome. Okay. Well, I'm just north of you in the Bellevue, Washington area. So awesome. Well, again, thanks for taking the time to spend with us and work through a problem. I hope this is a lot of fun. Just a little bit about me so you kind of know who you're talking to, and in case you have any questions. I was a software engineer for about 20 years. I mostly worked at Microsoft and then Facebook for much of that time. And then I've been at a couple of small companies since. Right now, I'm actually at Formation, which is a career accelerator, and I'm working on instruction, not engineering. So we have an engineering team, but I actually work on teaching and building content and helping engineers. So that's kind of my story. This is going to be a pretty much straight up coding interview. Okay. I have a question for you all ready to go in the coder pad. So unless there's any questions that you have, you can give the problem a read, and then hopefully you'll have questions at that point.
Let's go and get to the problem then.
Yeah.
Sure. So I have the coder pad open here. It says given a word, lowercase letters only, and set of tiles, lowercase letters plus underscore. Determine the point value possible for the word. The underscore represents a blank tile that can stand in for any letter but has a 0-point value. Points for tiles are as listed here. And I guess the example we have is the word is cat. The tiles are TMOCA. And the result is 5. 3 plus 1 plus 1 equals 5. So I'm a little confused.
That's okay.
Yeah.
That's totally fine. You're welcome to ask a lot of questions.
Okay. So given a word and a set of tiles, determine the point value possible for the word.
So effectively, we're going to try to make the word using the given tiles.
Okay.
And every time we use a tile, we will accumulate some score, right? So if you see, like on line 13, where I say the result is 5, if we look in the table, line 6, we'll see that the point value for a C is 3.
Right.
Right. And so we have a C. We can make that, so we can score that 3. And then the A is a 1 and the T is a 1. So it's possible for us to make the word, and the total score we will achieve making that word is 5. That make sense?
Yes.
Okay. So now let's look at the second example. The word again is cat. The tiles are a little different, right? We have the TMOA. We do not have a C, but we do have an underscore. So now this time we can still make the word, but we don't score that 3 points for the C.
Okay.
Because we used the underscore as kind of a wild card.
Got it. Okay.
So we do score a 1 for the A and the 1 for the T.
Okay. So it's kind of like a Scrabble game?
It's kind of exactly a Scrabble game.
Okay.
I try to not phrase questions in terms of things that I would like, oh, I've never played Scrabble before. And that is not a disqualifying thing to have never played Scrabble. So I try to phrase them in other ways. But yeah, it's Scrabble.
Okay.
And these are actually the Scrabble point values.
Okay. Yeah, I was a little confused about the second example with the underscore, but now you explained it well. Okay.
Okay.
Thank you.
Yeah.
So there's no numbers. It's just letters. Case does not matter.
Yeah. Well, let's just ignore case completely. And like I said on line 2, the word will be lowercase letters only, and the tiles will be lowercase letters only plus underscore.
Right.
I'm not gonna worry about throwing in white space or capital letters. That doesn't make the problem interesting. It only makes the problem annoying.
Right. Okay. So yeah, the first option that I see to solving this is just taking the word that we're given and just iterating over each letter and assigning each letter a value to give the result at the end.
Okay.
Yeah. So some other options, but I'm not really familiar or comfortable with.
Okay.
It's just, I guess, just with map, but I'm not too familiar with the syntax of it and everything.
Okay. So how would you use map? How do you want to use map?
So I think it's kind of like an object where you put in a key and then it returns a value. So we can do something like that.
Well, sure. But how are we going to apply it in this case to solve the problem? Like what are going to be the keys and what are going to be the values, and how is that potentially going to help?
Sure. So let's say if the word is cat, and if we have a map or an object to store the key, it'd be like the letter C is to 3.
Okay.
A is to 1.
Okay.
T is 1 as well.
Okay.
And we would turn the values there and put it into a result.
I see. So you're proposing that we would iterate through the word and use the map to count the letters in that word.
Yes.
So I'm sorry, I said the wrong thing. Are we counting letters or are we assigning point values?
So we would be assigning the point values. Yeah, sorry.
Okay. So how would we deal with a word like?
So it would just give is it because there's 2 C's? Is that what we're concerned about?
Yeah.
I guess it will iterate through every letter still, so it would still give the value twice, I think.
I see. So what you would end up with here is a V, which is what 4, and then an A is the 1, and then you would end up with what here for the C?
Would be 3, but then it would go over the word again, and it'll do another value. And it'll add everything together, right?
I see. Okay. So if you use the same key twice in a map, what happens? Like if you do M, like let's just assume M is a map. If we do M of C, 3, and then we do M of C equals 3, what's in the map? We'll just say like M is a empty map. Right? What's in the map after line 31?
I am not sure. Would it just be C 3 still?
Yeah, it would just be one C mapping to a value of 3.
Got it. Okay.
Yeah, or if we did 4 here, the value would be 4. So we wouldn't end up having, it wouldn't look like this. It wouldn't look with 2 C mapping to 3s.
I see. Okay. So for that, then I guess this solution wouldn't work.
Well, it doesn't work as we've described it so far.
Okay.
But is there anything we can do to maybe solve that problem, or can we use a map in a different way, or do you want to go back and explore your first approach more?
Yeah, we can do that. I think that's something we can
All right.
definitely solve. Yeah.
Okay, let's it's your call.
Okay. So for that, we would just do, I guess, create like some type of dictionary to put all the values together.
Wait, are we sticking with the dictionary approach, or are we going back to your initial approach?
Sorry.
It's okay. I mean, I just want to know where we're going. It's okay.
Let me see. I guess initially I had the idea of just doing a bunch of if statements, and then if it's A, then return 1. But I don't know if that's too much.
I mean, there's pros and cons to everything, right? That's why this is engineering.
Okay, so let's go with that one, since I think I can do that part.
Okay.
So we'll do a function. Let's do that. So the word, and then so we'll do a for loop to iterate through each letter of the word.
Now, remember,
Sure.
we're given 2 things.
Oh, okay.
Okay.
How many tiles do we have?
Yeah.
Okay. So is one of the things is if you can get that word, or?
Oh, like, are you asking if it might not be possible to make the word?
Yes.
Yeah, it is definitely not always possible to make the word.
Okay. So I guess that edge case is if word does not include tiles. Let's see.
Well, let's pause for a sec.
Sure.
Let's come up with a handful of examples. So, like, I gave you 2 examples. Let's come up with some more. Let's actually like find a bunch of interesting cases. So you just correctly identified one of the other cases, which is, hey, wait a minute, we might not be able to make the word. Let's actually list out some of those cases.
Okay.
You know, we can just extend my comment block here, and let's write out some more examples.
Sure. So let's say another word of dog.
Sure.
And add the tiles of A, B, and C.
Great.
And then
So what's the result here?
I guess we can say invalid.
Yeah. So this is an interesting choice. Let's just say it's -1, right? Since we're returning a number, a score value. Let's return a score value that's clearly like outside of what we expect, that we can easily test for.
Okay.
Rather than like, in some cases we'll return an integer, and other cases we'll return a string. Like,
Oh yeah, that's
it's a little hard to deal with.
okay.
Okay, so that's a good test case. I like it. Let's come up with a couple more.
Sure. So another one would be, I don't know, would be, let's do another animal, a duck.
Sure, I like it.
So,
Yeah. So what's an interesting test case? Like, how can we like push the bounds of our understanding of the problem?
let's see.
Yeah. Trivial test case like this is also always good.
Yeah.
Like, can we make a duck out of a duck? Yes. So not to say there's no value in this, but we should be at this point really exploring the bounds of the problem and our understanding of the problem.
All right. Okay. So I'm trying to think of other interesting examples. I can really.
Yeah. Here, you think of another example. I'll fill in the answer on that one.
Sure.
So what are you thinking about?
Just nothing, no crazy examples pop up. The only one was like, if you had all wild tiles.
Yeah, I think that's a good case. Yeah, I like that one.
Yeah. Like that.
How many? Wait, let's put a note in here. 1, 2, 3, 4, 5. Okay, that's 5. Right?
Mm.
We can make a snake. We can make a duck. We can make a dog.
Yeah. And
we
then
do not get any points.
I guess for the word, does it have to be an actual word, or can it be like any?
Oh, that's a good question. Yeah, let's not worry about valid words or invalid words at this point. Yeah.
Okay.
But come on, I liked our animal theme.
But yeah, no. Yeah, I can't think of any other.
Yeah, no, I think that's a really good one. All right. Okay, so how do we then start to write our code in a way to handle these different cases?
Let's see.
Or how do we structure our code?
I'm not too sure. Let's see.
Well, here's a question. Based on the code you were starting to write at line 34.
Okay.
At what point do you know if you're not going to be able to make the word?
At the beginning, when we receive our parameters.
How do you know right at the beginning? Or how will the computer know right at the beginning?
If the word has the tiles in the word.
Okay. Can you express that in one line? By the way, that's not a challenge. This is a rhetorical question.
Oh.
We will write the densest code possible. No. Let's not do that.
I'm not sure.
So the thought you expressed of like, yeah, we need to check to see if the letters in the word are available in the tiles. That's the right concept, right? But we need to take that concept and break it down into steps that the computer can do.
Okay.
So we can't just, I would argue we can't just know this at the beginning. We're going to actually have to write some code to figure that out.
Okay.
Right. And so now we've now identified two things that this code needs to do, right?
Right.
It needs to determine if the word is even possible given our tiles. And if it is possible, it needs to total up the number of points available.
Right. Okay.
Right. We could potentially do that as two different steps. Like, hey, is this possible? Check it out. Right. Mm-hmm. And then as a second step, hey, we know it's possible. Let's find the score. Or we could actually do these in one pass, in one step. I actually don't care which way we do it. But both of these operations are going to take more than one line of code.
Right. Okay. So yeah, I think separating it would be better for me.
All right, let's do that.
But now I'm not too sure how to do that. Let's see.
So you started writing a for loop on line 35.
Yes.
Where were you going with that? And actually, I might even recommend at this point that we don't write code, that we actually write comments.
Okay.
And we actually write in comments the ideas we want to express, and we can iteratively break those down to a level where they can look more and more like code.
Right. Okay. So yeah, let me write some comments here.
Yeah, like what do you think the steps are going to be to accomplish these tasks?
Okay. So initially I was thinking of going through
I'm gonna
through the word.
just typing in what we decided. So you keep typing. I'm going to type around you here for a
Okay.
second. It's good.
Okay. And then checking the value of each letter. And then learning the sum of values of letters.
Wait, so hang on here just a sec.
Sure.
Because we decided we were going to do this in 2 steps. Step 1 is the word possible with these tiles, or not for these tiles, with these tiles. With these tiles. So then step 2, if the word is possible now, sum up the total points. Right. So these are our 2 steps.
Oh yes.
Which
So
step
this
are you working on right now?
Well, this one should be the second step.
Yeah. Okay, good. Yeah. So this is why I like this sort of like high level sketching and like comment approach, because it helps you keep your thoughts organized in terms of like, well, wait, what am I trying to do right now? Oh, I'm checking for possible. Later on, yeah, there you go.
Okay.
Okay, cool.
So yeah. So for that one, I think should be good. But the first part is I'm not sure how I would go about this. So how to check if we have, the tiles are in the word.
Okay, so we're going to check if the tiles are in the word, or we're going to check if the letters of the word are in the tiles.
Yeah, sorry.
Which way are we?
Check letter of words in tile, yes. In tiles.
Here, I'm going to just give ourselves a little bit of space here. Yeah, there we go. I'll give this one more just. Really dislike this editor. Never does what I expect it to do.
Yeah, so for this one, I'm not too sure how I would go about this. Check the letters. Yeah.
So it sounds like we're going to need some iteration over the letters of the word.
Mm-hmm.
And then we got to figure out if that letter is in our tile set.
Okay.
Yeah, so like, I think the comment on line 39, we're actually going to do something similar, right?
Right.
Iterate through the word. Check to see not what the values are this time, but like, hey, do we have that letter?
Okay. Yeah, so if I do a for loop for that, how would I compare it to tiles?
Yeah. Yeah, there's a couple things we can do here.
Okay.
One question, do we want the parameters, word and tiles, are those going to be strings, or are they going to be arrays containing single characters? We can trivially convert one to the other, but
yeah,
if we have one, we can convert it to the other, whichever way. But let's actually get crisp about which one we have, so we know what we're working with.
Sure. Let's say they're arrays, since I think.
Okay, let's just say they're arrays.
Yeah. Not. We'll just keep it word and then.
Yeah. I'm going to add a comment here, just saying these are arrays of single characters. Okay. Cool.
Okay.
All right. So we've got arrays. How can we look? How can we look in an array and determine if something is there?
That's what I was not too familiar with. I know there's includes the method, but I never used it.
Okay. I mean, we can also write a method to do that as well, right? We can write our own.
Okay.
Yeah, but you're right. There is a function in a JavaScript array that we can use to find out. We can also write it if we have to. It's okay. Mm-hmm. It's a simple for loop. Actually, that's probably a worthwhile thing. Let's do that. So we'll just call it contains. Mm-hmm. And we'll give it an array, and we'll give it a character. Okay, so let's just write this for starters. So this is going to return now Boolean, a true false value. Yes, this is in the array, or no, this is not in the array. So how do we write that?
If you said C is in the array?
Yeah, this is to test if C is in the array.
Okay, so
true if it is and false otherwise.
Okay, so I think we would just do like a for loop and then loop through every. Yeah.
Great, let's do it.
Okay, so for I equals 0. I is less than the array. Increments. So if C equals to array ith, and it's kernel path 2.
Yeah.
C, yeah. Would that work?
It kind of almost works, mostly works. So if it's a Boolean function, there's one return statement, and that particular return statement always returns true. We probably want to return false at some point.
Oh, yes, of course. False. False.
Okay, but do for loops get an else statement? Do or an else block?
Oh. Right.
Yes. Yeah, there we go. Yeah. Now, it would actually work without this because it would return undefined, and undefined is falsy.
Oh, okay.
But this is much better style and it's much clearer, right?
Okay. Yeah, it makes some sense.
It'll break less code also, because what if a caller was actually explicitly testing for false? Is undefined false? No. Right? So yeah, this is much better. Okay, cool. So now we have a way to test if our tiles array contains some letter. Now let's jump back down and start thinking about using that.
Okay. So down here, if we do a similar thing, how would I use the contains? Function.
Yeah, well, I'm looking at your note on line 43.
Okay. So if we put words, so if we call the contains let me see.
So how many times do we want to call contains?
So this one takes an array and checks if it's this letter. So as many times as there are in tiles, how many tiles we have?
So are we? So yeah, we're definitely going to call contains more than once.
Uh-huh.
Are we going to iterate over tiles and call it once per tile, or are we going to iterate over words and call it once per letter in the word?
Probably over the word.
Okay.
Okay.
I like it.
I'm still a little confused on how to implement it here.
Okay, well, just like we're iterating over an array on line 34, like word is an array of letters. So we can pretty much use the same type of for loop to iterate over those, to iterate over the letters in the word.
Okay. We'll start with that. And the for copy paste here. And change this to word. So here we'll say if word contains or in the future.
Well, remember, contains is going to return true or false. So can we call it right here and then make a decision about what to do, or can we make a decision at this point about what to do?
Okay, so so if it has the tiles, then it would return true, and we can
then contains will return true.
Yeah.
And what can we do at that point? And when it returns false, what can we do at that point?
Okay, so if it returns true, then we can do the next step, the summing total. And
okay, how many times does it have to return true?
The whole word.
All of the time. Yeah, right. Every time we call it, it has to return true.
Yes.
Right. If it ever returns false, then what are we going to do?
I see. Then we'll do the -1 result.
Right.
Okay.
Okay. So how do we make that work on line 45?
Okay. Let me see. I'm so lost right now. Sorry.
Okay. All right. So let's just call. So now what's the question we're asking of contains? What is the array we want to pass, and what's the character we want to pass?
Okay. So I guess the array would be tiles.
Okay. Yep.
And then it would be the word did I.
Yeah. Okay. Let's do it.
Okay. Oh, sorry. So contain tiles. Would it be after it?
Yeah, because it's going to be array. Like, look in here. Look for this thing.
Right. Oh, okay.
Yeah. Okay. Cool. And now, so it might return true. It might return false. One of these two cases, we can make an absolute determination of what our final result is going to be. Is it the true case or is it the false case?
The final result?
Yeah.
Is it both, or let me see?
No. Only one of the two cases we can make a final determination of what our function should return.
The false one?
The false case. Why is that?
Because we haven't determined the total points.
Right.
Okay.
Yeah. Okay. So let's make this the false case. Let's say if it doesn't contain, right? Or we can do that by like, if contains returns a false, then what do we want to do on line 46?
Then we will return a -1 here.
Yeah. Yeah. Okay. Let's do this. Let's put a return 0 here for now. Right. So at this point, we're either going to return -1 or we're going to return 0. That's cool. Let's test this.
Okay.
Right. Let's actually test this on a couple of our cases. I'll put in the first one here. Okay, so we're going to have C, A, T, and we're going to have okay, so that looks right now, right? And we expect this now to return 0, which isn't the correct answer in the end, but that's fine. We know that we know that it's possible, not a -1, right?
Yeah.
Okay, so let's run this. Okay, we got what we expected. I'm going to hand it off to you to put in a couple other interesting test cases, and let's see what this does.
Okay, so let's say if it doesn't have
We could just copy this line and start modifying it to make some of our other interesting test cases.
so let's say we don't have any tiles, and how do we run it?
You can hit the run button up at the top. Okay, actually -1 is right. We just didn't update our expected result.
Oh, okay, I see.
Yeah, it's just sort of my little style here of like, hey, we tried this thing, we sort of wanted to get that. Did we get it? Yeah. Yeah. Okay. All right. So far we're passing a couple of test cases. Let's try a couple others.
Okay, so I think if we have the wilds, okay,
Yeah.
anything to work with that.
Yeah. So what do we expect in this case?
It should be 0.
Why?
Because actually, if we had 1, I guess, do we need 3 wilds for each letter, I guess?
Yeah.
Okay, so if we had 3 of these.
Well, I think this is still a good test case.
Okay.
So we should have both. We should have a 1 wildcard case, which we expect a -1, and we should have a 3 wildcard case,
Right.
in which case we would expect a 0 at this point.
Okay, something like this. Oh yeah, because we didn't code that out yet.
Yeah. Yeah. Well, because we haven't handled wildcards yet.
Yeah.
Okay, cool. Let's what about oh no, actually I want to grab this one. Like this is this is one of our test cases that I gave you above. Let's actually put that one in. Let's also just put in what if it's a funny version of cat. So in this case, we expect a 0 because we'll use the wildcard in place of the A.
Mm-hmm.
And then in this one, we would expect a -1 because we don't have enough A's. So actually, let's put the A back in here to make it a little easier to understand what's going on. In this case, we're still going to want a -1 because we don't have enough A's.
Yeah.
So let's run that. Yeah, and we'll see that now we've got a bunch of discrepancies here, right? But we're making progress on the problem. Okay, how do we need to change this and update this to start handling some of these other cases? So we haven't done anything with wildcards. For starters, that's one. I think there's two problems here. That's one of them.
So wildcards, I guess, for this that contains, if, can we put or here? Or underscore? Would that work?
No, not quite. Although I see what you're trying to do. We can express that same thing this way by doing an or, and then right. So like, is that character the thing we want, or is it a wild card? I would actually argue against this approach, right? Because what we're doing is we're taking a function that had a very simple idea and we're making that more complicated. I think we can do this same thing in another way that's a lot more clear. What we could do is we could call contains with the letter like we're doing on line 45.
Okay.
And then if that doesn't give us what we want, we could try calling it again with an underscore. It's like, oh, you didn't have a C. Okay, well, maybe that's fine. Do you have an underscore?
Okay.
Right. We can just call the function again. And that keeps our function really clean and simple and single purpose, right? And kind of makes it easier to test, easier to debug, easier to reuse. I love functions that are very short and simple and express a single idea clearly.
Okay. So where would we put that? Would we put it in an else if down here, or?
Yeah, we could. Well, is it an else if? Like in what situation do we want to check for an underscore? Let's put it that way. Is it the case where we have the letter in our tiles, or is it the case where we don't?
When we don't.
Yeah. So that's now in here. So on line 45, we're checking, hey, do we have the letter? And then now if the answer was no, we got a false. Excuse me. Now inside that if statement, we can check again, like, oh, well, you didn't have that. All right, try to. Do you have a wildcard? Do you have an underscore?
Oh, okay. So are we able to nest them inside of each other?
Yeah.
Okay. So we'll do the similar things. And underscore.
Yeah, I think we're just missing a paren there.
Oh yeah.
Yeah, there we go. I kind of dislike auto indenting systems. That's okay. Yeah, okay. So if the character isn't there and we also don't have an underscore, then yeah, get out of here. -1, we're done, right? Mm-hmm. Okay. Let's run this now. Yeah, okay. So we're now passing a few more test cases and we're still failing, it looks like 2, the last one and the second to or the third to last one. Here, I'm going to group these things together here. Yeah, that one. Right, so why am I? Okay, so yeah, so why are these two failing?
The 2 on bottom is because we haven't done the summing part yet.
No, it's not this. It's not that we're not doing the summing yet. We're not even testing the summing yet, right?
Oh, okay.
Because we would actually expect we actually expect a -1 here, right?
Yes.
We don't even expect to get to the part of the algorithm, like the step 2 on line 52. We're not even expecting to get there. But in fact, we are getting there because we returned a 0. But we expected a -1. So what's the situation that we're missing?
Let's see. So they don't have the word or the tiles underscore, then it should return -1.
Well, like look at I'm going to move one more line, even though it's passing. I'm going to move that to the bottom. What's the difference between this line? Why does this one work? That one doesn't.
This one right now only has 1 wildcard, so it's only...
Right. Yeah, so we don't need to just check if we have that character. We need to know if we have enough of them.
I see. Okay.
Yeah. So this is where we might want to use a map, or if we find something that we can use, we might want to remove it from our tile bag, right? Like once we find like, oh, we're going to use a C. Okay, well, once we've used the C, we're done. There might be another C, but we've used the first one. And then similarly, like if we use a wild card, okay, well, now we've used it, we can't use it again. So we need to either modify our tiles array by removing things once we've used them, or we need some other strategy. And here's where your map idea from the very beginning, this may come into play. Because if we have a map that counts the number of tiles we have, oh, we have 1 underscore and we have 1 T, right? Once we use the T, we can change that 1 to a 0, and now we know we don't have any more.
Okay.
So we can keep track of things, via counting that way. Or we could just modify the arrays and actually remove things. So I think this is actually a really good place to stop. Do you have questions for me?
Many questions, but I'll leave that for another time.
Give me 1 or 2. I mean, this is a potentially very valuable part of the conversation.
Yeah. What do you think? Like some of the fundamentals that I should be learning. Sure.
Okay. Well, we were going to get there no matter what. So you're jumping straight to it, and that's fine. Yeah. Okay. So the bottom line is, you should definitely be very comfortable with maps, because that is something that comes up, especially in front-end development. When you're working with information being handed to you by a user who's actually like hammering on the app, like they come up all the time.
Okay.
So, kind of as a sort of a strategic thing, definitely practice with maps. The second thing is, and this is a really common situation, especially in interviews. And I see people all the time take a problem and jump too quickly into code.
Okay.
And they jump into code before they've thoroughly understood both the problem, which is step 1, understand the problem, and 2, understand the idea that they're about to implement in code. If you don't yet understand the idea of the algorithm, there is no way you're going to get the code right with any reasonable probability, right? You always have an idea, an intention when you go to either write a function or even make a change to a single line of code. Your idea may or may not be right, and that's okay, right? Like we all write bugs from time to time, right? But if you're not writing code with intention, then it's hard to even know if what you wrote is good or not. Like, I intend to write this, okay, for this reason. Does it do that? Does it get me anywhere towards my goal? Right now you can ask a question, right? And so even if it doesn't work, you have the opportunity to be productive, right? But if you're writing code before you fully understand the problem and without intention, then it's really hard to even ask yourself a question of like, do I like what I have? Do I think this is going in a good direction? Because you don't have something to compare it to. You don't have an idea of an algorithm in your head to look at the code and like, does this implement the algorithm? Right. And like, I see this a lot where somebody will write a line of code and I'll ask them what the line of code does. And they answer by reading the line of code. And that immediately tells me that they didn't write that line with intention, right? Because I can read the code too, but what are they trying to accomplish? Like, what is that supposed to do? Like, why are we iterating through an array, right? So getting really clear with and clearly delineate the steps in your problem-solving process, you'll make fewer mistakes, and you'll actually turn what might otherwise be a mistake into an opportunity to correct it and actually get the task accomplished, right? Because you'll have that basis of comparison.
Right. Okay.
But like, this is really common. I think this happens in interviews a lot, just because in an interview, there is very real time pressure. Like, we have a limited amount of time, to talk with each other this afternoon. And in a real interview, this might be the first one of 4 or 5, right? So after this one, like, we have to be done because the next person is going to like be jumping onto the call. Mm-hmm. So there is time pressure, and that's real, right? And so there's this perception that, boy, you better just hurry it along and write the code. But if you haven't like intellectually solved the problem yet, you're probably actually going to take more time because you're going to make silly mistakes.
All right, that was the interview. So, I mean, kudos to Tin. He's still going through his current coding boot camp, and he decided to take a challenge that was very, very difficult. So, and I think he handled it really well. He's a humble guy, and I appreciate that. I think a lot of employers are going to appreciate that. So, good luck with your journey, Tin. Hopefully this is helpful. This was problem 1 out of 2, so we've had 2 people so far that haven't gotten to the second problem, but we are doing one more mock interview that's going to be released in about a week from now, and I'll give you a heads up. This person, we already recorded it. This person did reach the second problem, so you're going to get to see that. But yeah, shout out to Formation. I appreciate Daniel coming on and doing these mock interviews. So yeah, that's pretty much it. Let me know what you think in the comments. I'll see you in the next interview.